Welcome to Virtualize Your Data Structure. My name is Brent Raymond. I'm the Senior Software Architect at the Art Institute of Chicago. I'm also the organizer of the 4D Method user group, as you might have heard this morning. Come see our website at 4dmethod.com. I'm going to go ahead and get started on the slides here. There's a lot of material. Start with an introduction, or as they say online, a TLDR, too long didn't read, abbreviated form of what I'm going to talk about. A virtual structure, as it's defined by this session, is an abstraction layer for data and functionality that contains information that can be accessed by generic code to deliver application-specific behavior. Now that's a mouthful, but we'll get through it. But this is a different kind of a session. It's not new features in 4D. We've been doing this for a long time in different ways, and this is currently going to be using 4D objects to store information about the virtual structure. But it's been around for a while. We'll go over some background, a description. We'll do a sort of a project management style analysis of the strategy, look at a case study from the Art Institute, and go through the example database, and hopefully we'll have some questions. Here is one of the main interfaces for our application at the museum. Now, on the surface, it doesn't look like anything all that special. Up here, you have place to do multi-field searches with specific tokenized values, a record area where you can add all kinds of different fields and different categories. You can store the searches, you can store the selections of fields that you're looking at in the record area, and you can store store and share the selections of the records. What's interesting about it is this interface is completely generic. So the same code is used for different tables, and it works with the virtual structure module to pull properties of the tables, properties of the fields, for how they're used and how they're rendered in the interface, and where the data is pulled from, the queries, what the logic of the queries are. So a little bit of background, or as they say, and I'm also referencing some Reddit terminology here for background, of course, the subreddit history. And I'll get to why I'm doing that later on. As I mentioned, this strategy has been in use at the Art Institute of Chicago with our application CITY, just an acronym, along with all the other acronyms out there. It's been in use since the early 2000s. I didn't make this, wasn't my idea, but I think it's pretty cool. It was developed originally by Stefan Luque and Michael Blossom, some of you might know them. They're not in 4D work anymore for some crazy reason, but they've all moved on. But their ideas were heavily influenced by the writings of David Adams, and now Ed Hammond and I developed CITY and work on the virtual structure module and extend it today. So a little description, or as they say in Reddit, today I learned. This is just a general programming concept. It's not specific to 4D. You could do this in any language and anywhere where you're dealing with data or any structured information that you're trying to share with people. It's just, at its most base element, a data structure, a data dictionary per se. It has tables, fields. The tables don't have to actually exist in the 4D structure, neither do the fields. The fields per se could just be a formula or combinations of other fields or information from external sources. Some of the properties that you would find in the virtual structure definition would be stuff like the access definition, the callbacks that are used for query and retrieval, what security privileges should be checked and privacy restrictions of the data, rendering the appearance of the fields. So, something like a column width, or you could even put in what font you want to use for this particular field. Is it bolded? Controlled list values, so this field only accepts values of these types. The relations that the data follows for these field values and the data which it's pulling from, and functionality, general functionality properties. Really, it's up to the designer, the information that you put in your virtual structure. The registry is accessed in turn. Your virtual structure registry is accessed by generic code. In fact, anywhere you have a property in the virtual structure, it pretty well points to a place of the application that has been made in turn generic and can handle common classes of tasks that you have in the application. The application can be, in fact, if you really buy into the idea, you can extend your application by simply changing your virtual structure registry. You can just add a field willy-nilly just by saying, hey, there's going to be a new field. It's going to be handled like this. It's going to appear over here and have these security restrictions. The new, well, that's the next point. But yeah, another benefit of it is that a single 4D database can be run in different modes simply by activating sections of your virtual structure. New properties are easy to add because once you've got it all set up, you just declare a new property and then you use it somewhere. Somehow, doesn't matter, it's up to you. And another big benefit is it can become basically a living documentation of the data in your system and the functionality of the application. So you can say, it maps itself due to its very nature of being your map that your application references. For some analysis here, or as I say on Reddit, explain it like I'm 5, I'm going to leverage a project management style of approach called a SWOT chart. You look at the strengths, weaknesses, opportunities, and threats of the strategy based on whether they're helpful, harmful in their origin, whether or not it's innately a strength of that approach or if it's just an external benefit of something that opens a door for you. And I'm going to try and get through all this so we can take a look at the code. So I'm going to try and move pretty quick. Strengths, of which there are so many. The naming and data constructs are independent from the 4D structure. The naming, you can change the names depending on where the application is being used, languages, so on, or the mode that the application is running in. It allows for easier user navigation of multi-table relational chains because they just don't see that. It limits structure bloat, as in when you're storing, whether you have a logical field that you don't have to have a pre-calculated value stored somewhere. It's just calculating it on the fly. It helps to unify the data presentation due to the centralized nature of the query and retrieval callbacks. All of the data is being queried in the exact same manner from the exact same method, and likewise with the retrieval. It can have the effect of simplifying data access in the code because as opposed to having that logic repeated anywhere that you reference that field, you're just referencing in turn actually a constant which represents that field, which again doesn't have to actually be a field in your database, your 4D structure. It facilitates access of data from external sources. Again, none of the data actually has to live in 4D. You could be referencing other SQL databases, other APIs elsewhere, and yet it looks like it's a field in your database. As I mentioned, it's self-documenting for stuff like API access. All you have to do is say, this field is going to be available in my API with this particular name, and everything else, the API can just draw from your virtual structure to define how it's going to be queried and delivered. And the by its nature, the centralized data access allows you to optimize, really concentrate on optimize your, the functionality, the structure of your data on the back end, and let it have system-wide impact, because everything is using that code. Weaknesses, okay. The built-in 4D user-facing interfaces, such as the query editor, the quick report editor, the labels, and all of that. It's no longer applicable because you're using you've gone off the grid. You're using your own 4D structure, data structure, which doesn't is not going to be available in those anymore. So that's kind of a bummer. Having direct external SQL access to your 4D database also circumvents the virtual structure, and also data retrieval tends toward a per field basis. So there is some cost there. You won't have giant strings of selection to array in this manner. Each field will be handled atomically, so to say. Opportunities. Okay. As I mentioned, it's really easy to run the application in different modes. At the and I'll get to it later, but at the museum, we're running the same code base in something like 6 or 7 different, very different modes. I'll talk about that a little bit later. It works. It's perfect for something like an access control system. So if you want to have roll your own field privileges for your application, or if you already have something like that, all you have to do is set up a reference between your virtual structure, your fields, tables, and what privilege it needs to check per field, and then that becomes actually, you can handle that generically. You ask it what privilege to check in your access control system, and then you get back an answer whether or not that should be available. It enables easier interface exposure of data stored in object fields, which is really cool, big advantage there. You don't have to worry about, okay, how am I going to expose this particular attribute that's buried in an object field, even though you really want to use those new object fields because they're great. This opens that door for you for a way to expose those in the same, it looks like a typical flattened out field. It encourages generic coding. Doesn't mean that you're going to do that. However, it's a good idea. And we'll have to, I think most of us here would understand that generic code is a nice thing to have. It scales well with data requirements. Some of the, you'll still be able to have your heavily normalized data in the background without having to worry about it being confounding to your users to be able to understand how the relations are. And again, with the object fields where it makes sense, you can do that, and you don't have to build out tables and to be big ugly messes. And it's really readily set up for such things as the execute on server method property. So you can really leverage that to handle all of your query and retrieval on your nice beefy 64-bit servers. And given the fact that you're not exposing your 4D structure at its raw level, the users are having to go through your access control, your virtual structure is having to refer to that. So if you've turned it off in the virtual structure, it just doesn't exist anymore. So there's inherently better data security due to the abstraction of the data access. Threats. It's additional work. That's a bummer. But in the end, it actually pays off. Once you have this set up, and you have these classifications of fields and types of tables and that sort of thing, it becomes less work over time because you're not having to repeat a lot of code and logic. it's a steeper learning curve for new developers. I had to go through it myself. I was confused. I'd never seen this before. It's odd. It's not what I see everywhere else in 4D, and that can be a challenge. And I'm sure Ed would agree with that. And if Mike, are you here? Mike Rommel? No? Okay. That's probably why. But it can be difficult to explain to those with less systems engineering experience, and it can be a challenge to explain to anyone, as I'm sure is evident currently. So, big disclaimer, the virtual structure strategy is not right for every application. And, but hopefully you'll see that it has a lot to offer if you do go through if you do roll it out and implement it. So, getting to the case study of our system at the museum, or as they say online, pics or it didn't happen. And here's a few jazzy pics from our collection. Some really neat art at the Art Institute. I invite you all to come visit us if you're in Chicago ever. So, as I mentioned, our application is named City. So if I refer to City, it's not just the city of Chicago, it's our application. Our main business is art, so our primary table is artwork objects. The actual table structure in 4D has 63 fields, most of which are actually only used in a specific mode of the application, namely our web serving. But the interface and our API for objects show that we have 347 fields. So, how did that happen? We have 231 tables in the 4D structure. As I mentioned, it's heavily normalized. We probably could easily have double or triple that if it was done a different way. But the users are really only aware of 9 tables. The virtual structure masks the complexity of the data structure, and so that you can keep the glorious yet potentially confounding database design that you've dreamed up and seems to work in your architect mind, and limit it to a sort of a flat list of fields that people don't have to really understand where the data is coming from. It just is that field for them, and they don't have to know the technical side of things. So, at the museum, for our purpose, user-defined constants are a must. Does anyone here use user-defined constants? Ed? Of course. Okay, a couple of us. They're really easy to create with the 4D pop component. We'll look at that a little bit when we get to the sample code. All of the virtual structure elements, the tables and fields, and their properties, like their name, such things like that, all have an associated constant. If you put it together with a predictable naming convention, like if you see here, our fields are prefixed by their module, their table, agent, virtual field, and then their name, then it can be really easy. It's actually pretty nice. You can use the autocomplete, and it's a lot more readable than having a field number or something like that. Our constants browser doubles as a sort of virtual structure inspector. If you see here, there's a list of callback methods. In our inspector, you can, given the new capabilities of 4D recently, you can just double-click on those and open up the method, or the way this is architected, you can double-click on the field name or the constant name, and it'll open up an analysis of that. And so you see in this picture, there's a hierarchical list box that you can browse the properties that you've defined. And there's also a 4D object breakdown of what those properties are as well. Again, wherever you see these virtual structure properties, they point to pieces of the application that have that are basically generic. So The more you have in there, the better. Right, so this is just a field in our table. The field has a number of 4, that's its constant. That's its label. You can make the label whatever you want, depending on how it's registered. It doesn't change anything in the background. And so on and so forth. Category, the callbacks, and the field model, which is our field type, handled in a specific way. Yeah. So coming to our access control at the museum, these are all the privileges. Every single field has view and modify privileges, along with functionality throughout the application. And access control is very important for our data, as you can imagine. It's a several billion-dollar art collection, and there's lots of buried secrets in there. The security module is all basically generic, as is this interface. It allows for different user roles by adjusting over 1,100 privileges. And the majority of, how do you manage 1,100 privilege values? Well, the virtual structure registration actually handles all that for you, because you're just setting it when you set up the field, and then you just set it and forget it. And if they have that checkbox on, then it's referenced automatically. But that's a really interesting use of the virtual structure. That might have even been where the idea was born, frankly. This is our search area for searching a table. Kind of some of the steps that it goes through is it goes to the virtual structure, and it looks for a list of fields that are enabled for searching. You don't have to enable a field for searching if it doesn't make sense. It checks the security that the user can actually view that field whatsoever. It gets a list of the search comparators, so you can create search comparators that have logic that is whatever logic you want to assign to them. Having keywording or includes or starts with or is before or contains, whatever. It sets up the entry according to whatever the field model is. So in this case, you see that it's a choice list, and when you click into that field, it not only has type ahead because it knows what the options are, but it has a drop down of the values that could be chosen. And then once you've filled everything out, it runs the callback method that you've set up for that field in your virtual structure. The data view area does the same kind of thing. It checks if you can view the field. It sets up the column width, which you can define in your virtual structure. It calls the data retrieval callback method. It sets up things like drag and drop, so that all of that is actually handled generically as well. And it will pull a list of sort of faceted filter values from the field definition, so that you can jump directly to those records with those values. Moving ahead to the data entry again, just don't want to beat the horse too much, but security privileges, loading fields, how they're displayed, where they're displayed, business rules for input, the generic kind of go-to jump to this field for me sort of thing. It's all it all draws from properties that we have that in the registration. And one last thing is we have a data batch change functionality. Most fields in City, whether they're just basic text entry or they have selectable values, or even when they have many related choices, like relating two of your major tables together, or many-to-many kind of relationships with qualifiers and whatnot. That is, again, all drawing from the virtual structure. So we are loving it, and it works for us. And again, we're running the same code base and we can run it anyways in up to 8 different application modes simply by flipping switches. That being, our production, our client-server mode, a mirroring mode, which blocks all data entry and communicates with production for pulling records that have changed. We have an internal SOAP API, a web publishing mode, which exposes only a certain portion of fields and a certain portion of records via an API to the outside world. And then other, obvious modes like developer, test, and maintenance, and crash recovery, which all manage access to data and, functionality that is controlled by those modes and are handled appropriately. A big plus that we've been able to leverage this strategy for at the museum is creating the custom API for your application. Someone who's far wiser than I said the best way to keep your application in use at a company is to make an external API for it so that people can access the data from whatever other application, whether it be web, mobile, sorry, my redneck roots are leaping out, but just allowing for access to your data in other environments, and it's just a really huge benefit to have for your system. So, and this is ready packaged for that. If you're interested, see some demo videos of City that I put together, 4D at the Art Institute of Chicago at the 4D Method site. There's a link here that's available in the keynote that you have on your stub there, on your flash drive. Okay, that was a mouthful. How am I doing on time here? Wow, good. Okay, getting to the example database. That was a lot of information. Let's see it actually work, and I like the subreddit programming. Just a quick overview. We have the example code broken up into a few different modules. Of course, the virtual structure module, the generic manager module, and a person module, which is the actual what the data is that's going to be leveraging the virtual structure and the manager, the generic modules. Right. This is fully functional, the code that's set up in there. You can use it for, even if you don't have as generic of a system as the Art Institute has currently, there's immediate utility, even if you're just putting this as a layer on top of your own 4D structure. So it's all ready to go, and it uses objects currently. So let's take a look at it. Okay, and here's my little cheat sheet. And so we're going to take a look at the virtual structure module first here. It's all broken out in the Code Explorer, and we tend to split things up into private, public, and shared folders, even though it's not really a component. We're sort of following that approach to our code. So the properties that I have set up in this test database are basically, as you see listed here in the property list. You have the singular and plural labels for the tables and fields. Sometimes this doesn't always make sense. Sometimes you want to have something specific for the plural name. A Boolean says it's a table or a field, the table ID that a field might belong to, and so on. Whether you can modify the privilege to say if you can modify, if you can search on this field. And currently we're using actually arrays for our virtual structure at the museum, but you can't unfortunately put pointers into an object in a table. I'll show you where it's stored. But anyways, so it's broken down into a table number and field number if it points directly to a 4D table field. the data type, whether or not that table uses the managers, the callbacks that are set up for it. All those are set up within our registration for this sample code. As I mentioned, we use the 4D pop component to make new properties and whatnot. You see these are the constants that are set up, but they all have a sort of a attribute name that we use in the 4D objects. So they have a object JSON ready version of their name, and you can add and delete new properties and new constants in the 4D pop readily. It's really easy, nice way to organize your constants. So all of these are the virtual structure itself is created and stored on startup or initialization into a virtual structure table. The definition, each record in the virtual structure table contains an object field which has all properties about that particular element, that field or that table. This is, again, just one way to do it. We're currently using synced arrays, which is another way to do it. You could store these objects in an external JSON file or a multitude of files, and you can handle it, control it all externally to your application. Right, so what does it look like? There's a little Explorer form here, and run form. Let's run it again. Okay, maybe it's back here. Uh-oh, it's curse of the demo. Ah, yes. Okay, so all these were defined basically on startup. That's just a UID. And here are the objects, and you can flip through them and see what their values are. So in this case, this is the first name, last name, country. It has all the callback methods. These are all generic callback methods. In this case, it's a person module specific callback method. We'll look at that a little bit, but you know, again, this is just one example of how this could be set up. You can do the same strategy in your own application and have whatever properties that make sense to you. Sure. Yeah. Please. Yeah. No. I promised myself I would do stuff like that, but I forgot to. So. I think mostly just because you don't need to. It would just be basically a pulling values out of the attributes, which you can handle otherwise. Yeah. 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 And you know, that could also be just done within the list box. You could instead of having this gnarly UUID, you could extract the attribute and put it there. Yeah, good question. Right. You know, it's all up to your own coding. So if you wrap your registration method that says you know what the label is going to be, you can check that against your current structure. You know. Obviously, it wouldn't make sense to have 5 first names, right? Yeah, it's all, you know. Again, this is just an example of how is it production ready? Probably not. You'd want to harden it up, you know. Like the callbacks, you might want to check to make sure those methods exist. They're going to be called through an execute statement, that kind of thing. You know, there are those things that can be done with this. This is just an exercise. Right, so getting back to the initialization, we have a VS init method here, which does nothing much more than actually calls these methods. And in this case, I've just broken out the tables and the fields into two different methods, just so it's a little bit easier on the eyes, and so you know better what you're looking at, but they could be combined or be external. You don't even have to use 40 commands to create this. Again, you can use whatever you want. Again, it's just assigning an identifying key for that. In this case, it's table 1, because I know what that value is, but a literal person, people, is it a table? Yes, it is. Does it point to an actual 4D table? In this case, it does, because that's easier. And we have it set up so that it has an associated fat text table. Maybe it's old-fashioned, an old-fashioned approach, but it's worked for us since the olden golden days, and so that's one of the things that I put in here. And it is actually really flexible, as I'll show you. In here we have all of the fields hook. Same thing, assigning it basically a number, but this is easier to read. Well, in this case it's kind of ugly, but this one looks like a first name for the most part. You give it a data type. You're saying that it is a field. What the field model is. In this case, I mean field model by it's a general text field in a table. And it specifically points to the UID field. It's using these callbacks, which are generic callbacks. You can't modify it. You can't search it, just because I said so. Another field here, first name, last name, same kind of things. Identifying what you can do. Can you modify it? Can you search it? What the callbacks are? What happens when you want to save something? What does it call when you want to save something? Those are all text fields. Those are all stuffed into a fat text table. And if I show you the structure, I'm basically registering these fields for use with the virtual structure, with the generic callbacks. And then we also have an example of how to do an object attribute type of field, which is referring to the people detail field. Let's see, there we go. It's just an object in the main table where you can stuff any number of fields that you want to put in there. Same thing with the text. You can put any number of fields in here. It's just pointing to a field number. So you could have 1,000 different actual fields in there. Doesn't matter. It's going to store them and handle them all in the same generic manner. And we have an example of a logical field, which actually calls this to assemble the data. It's just going to pull two fields and combine them together, first name and last name. So those callback methods are interesting. I'll let you guys go into that if you would like to on your own, but just 4D code, nothing crazy. So let's take a look at some of the calls that you can make to access your virtual structure. This is what's going to happen in the manager, but this is just a test version of that, just to play with the virtual structure. The first batch of calls here, you're pulling the label, the singular label for this person table. This is a person table ID, and we'll step through it here. Should make this a little bit smaller. But as you can imagine, oh darn, wrong thing. Yeah, it hasn't been called yet, so, oops. And it gets person. Imagine that. The next one, people, and so on and so forth. The rest is pretty predictable. Yeah, and the table number for the actual 4D table. A couple of Boolean values. Oh, doing the wrong key. Sorry about that. Right, Boolean value, is it a table? In this case, oh, it hasn't run it yet. Yes, it's true. Can everybody see that? Good. So on and so forth. And you can play with this. Again, list virtual structures where a property has a given value. So you're actually searching your virtual structure for, say, a list of fields or a list of tables. So in this case, you're saying, give me a list of table numbers. And that pops into here. Clearly, there's one table, and it has the number 1. And then a list of fields. And then we're going to get a couple of properties. The fields actually, I don't think are set up with plural names, but then this is how you get the names that you have set up. So it's pretty obvious how it's what it's doing, but we'll look at that really quick. It's using the query by attribute in this case to find virtual structures with that property, and that's pretty cool. Use of that new command. I've enjoyed using it personally. So again, in this example, there's some generic query get and save methods. Like I mentioned, you can also have very specific logic, whatever you want to do with the data, put into other callbacks, however you want to structure it. It's just an idea to hopefully give you other ideas at how this could be used in your own application. So let's take a look at it in the manager. This is, again, very simple. I'm going to add a record, gives it an ID. I'm going to click in, my name. I live here. And this is not enterable, but when it's displayed, again, this is not production ready, but yeah, so now it's there. I can add another one, just so we can look at the and then that's all saved. Using our generic callback methods, we can search on something like first name. I could do other fields as well. And so I've displayed basically the retrieval, data saving, and data searching. Now let's look at what's actually happening in the background. Right, so when you run this, let's see. Yeah, so it's calling, it's loading the data. Oops. It's doing things like getting a list of fields. Tell me all the virtual structures that are fields. It's pulling the singular labels for them all, getting the callback, the data retrieval callbacks. It's setting up whether they can be modified, the fields can be modified or not, and then it's just putting them into it's running the callback methods and adding them as a column in your list box. Again, you never see the people tables ever directly referenced in this generic code. And as you register more fields, they'll be added automatically and functional automatically in your generic code. Right. So and this is setting up whether what fields can be searched. Which fields have you turned on for search? Then they'll be in that drop down. In here, same thing for saving. What callback should I call for saving? And that's on data change in a cell. And then it just executes that generic method with whatever new value that you've entered into that field. And lastly, not right now, IKEA. Lastly, what happens as you search? Same thing. It's getting the property, the callback set, that you set up, and running that callback and then reloading the data. Again, not production ready. A lot of things you could do differently. Yes? Problems when we're trying to use transactions? No. I mean, the setting of the data, if you were to, in this case, it's very atomic. You're setting one field at a time, and if it were more extensive than that, if you had to call out somewhere or do several different tables, like in the fat text table or something, you wrap it all in the generic callback in this instance for anything that has to happen within a transaction. It's really just an idea of a starting point for whatever you need to do to save your data, and then beyond that, it's in your realm of what happens next, basically. So that's the manager. That's how it's being used. You might have seen that there's an application mode down here in the corner, just saying it's normal. We could change that application mode by, it's in here, where if I just, this is actually done on startup, but I'm going to cheat and set the application mode from normal to super. And immediately it redoes the registration and enables a new field to be made. And if I show you in the init, getting there, everybody. In the fields hook, when I enable super mode, it registers a new field, which is zip code, which is put into the object field. So you can create a new field without even changing your 4D structure, which is just really cool because, we all get a lot of common requests, such as adding fields or, fields are pretty important, of course, but, and whatever you can make generic makes handling all those requests a lot easier when you can just add something to your registration and boom, it's everywhere. You're able to batch change it, per se, in City. It's immediately available in your interface with the comparators that you set up with it, all the saving, all the business logic, what has to happen once that value is changed, what has to be informed, per se, with mirroring and whatnot. But yeah, so we enabled super, we reran the registration, and then we can see that field has now been added here. You can search on it. I'll put in a couple values. You could add some validation, per se, like callback for data validation to that field, so that wouldn't be acceptable. And then you could say search on it, but it's gonna, so you see it didn't. I should have put something more different, but you can see it's actually searching on it. You get the idea. So that's about it. It's all there in the example database. A lot of interesting stuff in there, but it's really up to you guys what properties make sense for your applications, and maybe you've already got some generic code that could leverage such things. Yeah, so now, as they say on Reddit, ask me anything. Question? Right. Part of this exercise was taking our current functionality and seeing how we could do it with the new objects, because it obviously is kind of ready-made for that. As I think Laurent said, these objects are associative containers, and it's perfect for these kind of virtual structure definitions. we did it before with synced arrays. And so as you create a new field, it adds it to, expands all the arrays, puts a number here, puts the values for the properties in all the other synced arrays, which was actually kind of cool because you could use pointers much more readily. You can't do that in stored objects currently. So there's a lot of different ways to do it. Again, it's just a strategy. How you do it, what you do with it is up to you, but we have found a just massive amount of utility in it. And in fact, in talking to other people from who write other languages and other systems, there's so many of the concepts are recurrent in other areas. Yep. Yeah, there's a reason. Yeah. Right. Exactly. Yeah. If I'd taken another approach to it, which I started with, and just registered them in memory, you could do pointers there. You can have pointers in an object variable, but not in an object field. But then you can't do the query by attribute, and there's no equivalent that I know of. Right. Mm-hmm. Yeah. 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 There's reasons. There's a. Yeah. No, it's not. There's ways around it. You just store a table and a field number if you want to point directly to an actual 4D field. But it's a little bit less beautiful than having a pointer to that specific field. Right. 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 Exactly. Yeah. That's a bummer. Yeah. Right. Right. Yeah. You can check for those things. Yeah. Right. Yeah. Seems like all advice is time bombed. So it's but again, do it however you want, store it however you want. It's just the concept of having this functional dictionary associated with your data in your application that you can tell it how to use this field, how to use this table, where should this table appear, where should this field appear, how should it appear, what do you do with it, what kind of checks and what security should be associated with it, and a whole bunch of stuff. Other questions? Yeah, so the whole thing with the Reddit is I made a subreddit for 4D coding and 4D subjects. It's that path, 4D apps. It's a subreddit for us. Hardly anyone's gone there or done anything on it, but I really dig Reddit because it's kind of like a nug where you can say, hey, I like this topic, and push it to the top. And that's what an upvote is. So if you're interested, which I hope you are, come and add some discussion to the subreddit. I don't know if anybody here go to Reddit for anything? One? Okay. Yeah, two. All right. Yeah. Somebody. So there's a chance. Thank you, everyone. For more information, that's my contact information, and thanks so much.